So in propositional calculus, there is something called indirect way of proving something. See, usually direct way means what? From the given set of premises, you will arrive at the conclusion directly. There may be some premises, something like this. See, P1, P1, P2, something, some Pn, and your conclusion will be C. So use all these premises and come to the conclusion C. This is called direct method. Another way is you may have some P1, P2, etc. Pn, but your conclusion will be of the form P tends to Q. Even you can use direct method to arrive at this, but in conditional proof what you do is, along with the given set of premises, P will be also considered as an additional premise, and you just prove that Q is true. That is, to prove P tends to Q is true, you assume that P is true. Whenever P is true, Q is true. That is the thing you are going to prove. So along with the given set of premises, you are assuming P as true and trying to prove that Q is true. So these two methods we have seen. The third method is indirect method. So what do you mean by indirect method? See, indirect method means sometimes, see, suppose I need to prove conclusion C is true. So that is, I am going to arrive at the conclusion C from the given set of premises P1, P2, etc. Pn. Right? From the given set of premises P1, P2, etc. Pn. So instead of directly proving C is true, I am assuming that suppose C is not true. I'll take that as an additional premise. P1, P2, etc. Pn. Along with that, I'm taking C is not true. Okay. Suppose P1, P2 alone, if you take, you have to arrive at C. But what I am doing is, along with the given set of premises, I am taking not C as an additional premise. Right? So I am assuming that no, C is not true. So I am considering that along with the given set of premises. So what should I arrive is, I should arrive at a contradiction. A false statement should come. That means, so whenever you assume something which is not true, then you should arrive at a contradiction. Clear? So whenever you want to prove something is what? True, what you have to do? Assume the negation of that statement as an additional premise, right? And try to prove that all the premises know, that is along with the given premises and the negation of the conclusion, together it leads to a contradiction. Clear? This is the thing I want to prove. Okay, shall we take one question? See, for example, first question we'll do. Very simple, then we'll do all these three questions. Show that not of P and Q follows from not P and not Q. Not of P and Q indirect method. Show that not of P and Q follows from not P and not Q. So in indirect method, that is what we have to prove. Not of P and Q implies not P and not Q. So using indirect method, what we have to prove? Direct method, no, directly you have to use this and prove this. But indirect method, what you have to use? And assume not of not P and not Q as an additional premise, which is equal to what? What is not of not P and not Q? P or Q. As an additional premise and arrive at a contradiction. That is the aim. Okay? That is not of P and Q, comma, negation of this, what you got? P or Q. this is equivalent to a contradiction. This is the thing we want to prove. So you have to use these two things and prove that these two statements are inconsistent. So indirectly what you are saying, this and this are inconsistent means what? Why this inconsistency has occurred? Because this is the negation of the conclusion. Since you are negating something, because of that this has happened. So this should not be negated. No, that is true. Right? So can you consider these two and arrive at a contradiction now? Just tell what you can consider first.
Not P and Q.
Not of P and Q. Yeah, this one. Which one? This one, right? Think and say which one. Have I taken first correctly? Not of P and Q follows from not P and not Q. Yeah, I have written here wrongly. Yeah. One of the 1 minute. This I have written wrongly. What should be here? This should be not P and not Q. Correct? This. No, 1 minute. Have I written correctly? 1 minute. What should I prove? Not of P and Q follows from not P and not Q. Here itself it is wrong. I have written the ulta here.
It's wrong.
So everything should be erased. So this is your given thing. This should be negated. So assume not of P and Q. So that is P and Q. So P and Q is your additional premise, right? Here what you have to prove? To prove not P and not Q implies not of P and Q. Charima, now clear, right? So this should be taken as an additional premise. Okay. Now tell me, you have to not P and not Q, comma P and Q is equivalent to false. This is the thing you want to prove. Okay. You have to take these two premises and arrive at a contradiction. So which one you can take first? Anything you can take, no problem. Okay. So I take not P and not Q. Given. So rule P. Next, not P. Simplification of 1. Simplification of 1. Now take P and Q. That is also given. Rule P. P. Simplification of 3. So consider 2 and 4 now. P and not P, which is equivalent to contradiction from 2 and 4. Just look into this once again. I'll say your aim is you have to prove not of P and Q follows from not P and not Q. So what I'm doing is I'm considering the negation of this particular statement and adding that as an additional premise. So what is the negation of this statement? P and Q. So this given statement along with P and Q should follow false. I think after this it's very obvious, very easy to prove. Just look into this, we'll go to the next problem. Shall we go to the next question?
Yes, ma'am.
Second question. To prove P tends to Q, Q tends to R, not of P and R, comma, P R R implies P tends to Q, Q tends to not of P and R, comma, P R R implies. So if you use indirect method, what you have to do?
Take not R as a premise.
Yes. So using indirect method, it is enough to prove P tends to Q, comma Q tends to R, comma not of P and R, comma P R R, comma not of is equivalent to, here equivalent to not implies, it's equivalent to false. All these statements together is a contradiction. Okay. How to start? Which one you can take first?
P tends to Q and Q tends to R. We can introduce.
Then
Then using hypothetical syllogism, we get R.
P tends to R. Then
P or R we can introduce.
or you can use not or. You can use not or, right? You can introduce that.
Yes, ma'am. Yes, ma'am.
If you introduce not or, 3 and 4, what it will give?
Negation not P.
Not P.
Using modest tolerance.
Modest tolerance. Then think and say. Next, what you have to use? Look into the thing. We have used all these things already. These three we have used. We are left out with two. Which one we can use?
P or R.
Huh? PRR. Sure. Okay. Then, shall we use 5 and 6?
We'll get R, ma'am. Disjunctive syllogism.
Disjunctive syllogism. So R from 5 and 6 using disjunctive syllogism. Okay. Then, could you see any contradiction here?
Not R and R.
4 and 7. R and not R. Hence proof. Okay, shall we proceed to the next question? Take down this question. The conclusion is not Q, not P. Okay, have you taken down the question? Okay. Question number 3. S tends to not Q. S tends to not Q, comma, S R, comma, not R, comma, not R biconditional Q implies not Q. Have I written correctly? Anything missing? S tends to not Q. SR, not R, biconditional Q. Okay, ma'am. So using indirect method, I'm taking the negation of this, right? That is Q. Just tell me a way how to proceed. If you want, you can write first. You write yourself and then tell. Take some time and tell me how to prove this.
First,
Huh?
S or R we can take first.
Okay, what should I start? Tell me. How should I start?
With the second one, S or R.
Okay, S, R. Then, good. Then,
Then not R.
not R. Hmm.
Then by 1 and 2 disjunctive syllogism we can
Yes.
prove
Yeah.
S is true.
So from 1 and 2, using disjunctive syllogism. Then
S tends to not K. Then using 3 and 4, using modest tolerance, sorry, modest ponens, not Q is true.
Okay. Okay, then
Then few.
Q is there already. Okay. This is
Yes.
called additional premise, right? Additional premise. So you have already arrived at a contradiction. Q and not Q, a contradiction from 5 and 6. Hence, this is true. The given thing is true. S tends to not Q. This implies no.
Excuse me, ma'am.
Yes.
So it is not necessary to use all the premises to
No.
prove that it's a contradiction.
No. See,
Okay. Since we haven't used one of the rules.
even if you are using something, negation of something that is contradicting with one of the given statement itself,
Yes,
whatever
ma'am.
we have that way, yes.
Yes. Okay, ma'am. Fine.
Uh,
Thank you.
no problem. Okay, you do one thing. Start the third question now. Take down the third question. Think about it and then. Have you tried this question?
Yes, ma'am.
Okay. So how to, okay, so first we have to write indirect method. That statement you have tried, then go for the proof. Sorry. Okay, tell me how to start.
We will introduce R or S.
R or S?
P and P not P and
I
P
think these two
tends to
will
Q.
be, or even you can introduce this, but what you can do is you can combine these two. P tends to Q, P tends to R, Q tends to R, no? P or Q tends to R. Some statement is there. R tends to not Q, S tends to not Q. That means R or S tends to not Q. You can combine like that. Then if you use R or S, you will get not Q, right? Then if you use not Q along with this, you will get not P. P is there, not P is there, contradiction. That is one way of doing it. But I think this is easy. Introduce P tends to Q. Then P. So Q is true from 1 and 2 using modus tollens. And then next step. Next, which statement you can introduce? In this sequence, if you go, which you can introduce?
S tends to not Q.
Oh, S tends to not Q. So use 3 and 4 now.
S. We get S.
Yes, sir. Simply yes,
Not S.
Not S, ma'am.
not S. What you are using actually? Modus tollens. So here ponens. Okay, ma, then. Yes,
R or S.
R or S. Then
From 5 and 6, R.
R.
Disjunctive syllogism.
Adjective syllogism. Then introduce R tends to not Q. Okay. Okay. Now from 7 and 8 not Q. Then Q is already true. From 3, not Q is also true. Hence, okay. Okay, is this clear? Indirect method is clear?
Yes, ma'am.
Let's start module 2 now. First we have an introduction to module 2. Module 2 is predicate logic. Propositional logic, simple sentences, atomic statements were used. We combined that using what, and, or something. Then we came to your conclusion, right? But in predicate calculus, we mostly deal with, see, in English there are two things. Whenever you read a sentence, there will be a subject and there is a predicate, right? So what is a subject and what is a predicate? No, in English, you have two things, right? Normal English, subject and predicate is there. What is subject and what is predicate?
Subject is like the topic or a object we're talking about,
Uh,
and predicate is something that's related to the object that we're going to talk about.
okay. Okay, correct. So subject is something about which we are talking about, and predicate is what we are talking about, that subject. Okay, so predicate logic actually is an extension of propositional logic, and it deals with what, reasoning about, not about a single person or something like that. We speak about maybe about the whole class, about some of them in the class. So we are going to use quantifiers in that. I won't say simply Rama. I will say there are some people. We speak about some people in the class, the whole class, like that I am going to speak. So I am going to quantify and talk. Propositional logic treats simple propositions as atomic entities. In contrast, predicate logic distinguishes the subject and its predicate. See, for example, in the sentence, the dog is sleeping. There is a sentence, right? The phrase the dog subject and is sleeping denotes the predicate. Because what we are speaking about the subject, that is the predicate, is sleeping. Okay, a property that is true of the subject, that's called predicate. In predicate logic, a predicate is modeled as a function. That's what I write like this. See, I can write like this. S of dot. The dot is replaced by anything. Suppose dot is sleeping. So if I use D here, dog is sleeping. I'm what, representing the sentence as a function type, right? S of X. X is sleeping. So at any time you can replace X by anything. Even you can write Rama is sleeping, Sita is sleeping, something like that. Whatever you want, you can replace there in the place of X and continue that, right? That's what. See, P of X. X is sleeping, where X is any subject. Here we are using P of X. It's up to us. One difference is there we use all small letters, maximum. Here we use capital letters, right? For lowercase variables denote objects. Uppercase variables denotes the proportional. Here, uppercase. See, can you see capital P of X we are using? There simply we use P. For to say dog is sleeping, we use P. Dog is sleeping. We write like this, right? So we can write like this. Dog is sleeping. But here, I am not interested in writing like this. Instead, I'll write. I'm differentiating what, the subject and predicate here. So P of X, X is sleeping. That way I want to differentiate. I cannot call this as a single sentence like this. So this is different way of approaching the logic. So keeping in mind that the result of applying a predicate to an object is okay. This is not the same thing what I do. P of x, x is a prime number. So you can replace x by something. 3 is a prime number. So P of 3. Suppose if I write P of 4. So what can you say about the truth value of this statement? 4 is a prime number. What is the truth value?
False.
False. P of 3.
True.
True. So shortly I am defining. There and there, then and there I can replace some values. Subject I am replacing, right? I am fixing the predicate and replacing the subject. So predicate logic generalizes the grammatical notion. Oh, all these things are so leave it. You can read later. See here one example. Even you can have sentence something like this. P of x comma y comma z. X gave y the grade z. What I can do is professor gave some Ankit the grade yes. So x instead of x I am replacing by professor. Y I am using Ankit, and for grade z, z is replaced by yes. It's up to you. You can replace anything. Generalized way I am writing. Then you can fill all x, y, z. Predicate is the same here. So the power of okay, there is something called a universe of discourse. I am going to say universe of discourse means okay. I am saying for example p of x we said right. X is a prime number. X is a prime number. So what could be the domain you can choose there? What and all x where it will come from? P of x I said. So just answer this question. P of x I said x is a prime number, right? This denotes x is a prime number. Can you say where does this x come from? What and all could be the values? What could be the domain of x? What you can fix?
Positive natural numbers.
Huh? Inama, what?
I'm like only from natural numbers.
Only from natural numbers, because we never speak about what? Negative prime numbers, something like that we never speak. Prime numbers always 1 to infinity. Correct. Only natural numbers. That's called universe of discourse. Okay. So from where you choose that x, that is called universe of discourse. See, let P of x denote, that is particular sentence, that is one what? Predicate sentence. It denotes actually x plus 1 greater than x. So x plus 1 greater than x. For what values of x this is true? For all? What and all, see, this statement is true, right? For all, what and all values of x this statement is true, I am asking.
All
Which
negative
statements?
values.
Minimum for? So only for negative values of x.
So
Suppose I take minus 1.3 plus 1. It is greater than minus 1.3. 2.3 plus 1. It is always greater than 2.3. 1.001 plus 1. It is always greater than 1.001. Minus 2.7009 plus 1. It is always greater than minus 2.7009. So now can you guess what will be the values of x where it should be chosen from? Is it true only for negative values or even for positive values?
All real numbers, I guess.
All correct.
All real
Yes,
numbers.
all real values. All real values. This statement is true for all real values. So you can choose your x. You can choose your values of x from the set of real numbers. Okay, I'll stop here.